Today is our first lesson in chapter 11, and we're going to be looking at lines that intersect circles. So you'll find that this lesson is very definition heavy. There are a lot of definitions, so bear with me and I'll go through all of them with you. So the first thing to look at is just a refresher on the definition of a circle. A circle is the set of all points in a plane that are equidistant from a center point. The interior of a circle is the set of all points that are inside the circle, and the exterior of the circle is the set of all the set of all points that are outside the circle. Okay? Coming to our first term that we're probably not familiar with is going to be a chord. A chord is a segment whose endpoints lie on a circle. Okay, so if we look at AB is a chord because its endpoints lie on the circle. Next, we're going to look at a secant. A secant is a line, different from a chord. Remember, a chord is a segment. A secant is a line that intersects a circle at 2 points. Think of that as a line that's going through the circle. Goes through it and it crosses at 2 places. So line L is a secant. Okay. Then we have a tangent line. And a tangent is a line in the same plane as a circle that intersects at exactly 1 point. Exactly 1 point. So in this case, line M would be a tangent line. And then finally, the last definition of this section is the point where the tangent and a circle intersect is called the point of tangency. Point of tangency. All right, and we would see the point of tangency is at point C right here. So those are our definitions. And then we can go through example 1 quickly. If we're looking for chords in example 1, remember a chord is a segment whose endpoints lie on the circle. Well, in this case, we could say that segment JM is a chord, and you actually can say that KM is a chord as well. Now, KM is a special type of chord because it is also the diameter, which is okay because the diameter, the endpoints lie on the circle. Next, we have secant. There's only one of those in this example. The secant here would be line JM. Also one tangent line, and that would be, the tangent line would be line M. The diameter, which we already talked about, would be KM. And then the radius, we could either say that it's LM or LJ or LK. All right, moving on. looking at pairs of circles, two circles are congruent circles if and only if they have congruent radii. So you can see here, because segment AC is congruent to segment BD, and because those are the radiuses, the radii of each circle, then we know that those circles would be called congruent circles. Next we have concentric circles. Concentric circles are coplanar circles with the same center. They have to have the same center in order to be concentric. If they don't have the same center, and they intersect at exactly one point, then they are called tangent circles. And here we see two examples of tangent circles. You have internally tangent circles and externally tangent circles. All right, moving on. In this example, they're asking us to find the radius of each circle. So the radius of circle R it's going to be 2. The radius of circle S will be 1.5. And then they ask us for the point of tangency. That's going to be, I'll use a different color here. That's going to be right here, and that point is -2, 0. Followed by asking for the equation for the tangent line. The tangent line is the line that intersects each circle at one point, and that would be this line right here. Simultaneously intersecting circle S at one point and circle R at one point, and that equation for that line is the horizontal line y = 0. Moving on to the definition of common tangents. A common tangent is a line that is tangent to two circles. We have examples here of common tangents. And then moving on to our next set of theorems, we have theorem 11-1-1 that states that if a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. So in this case, line L is perpendicular to segment AB, because segment AB is the radius of circle A. Theorem 11-1-2, if a line is perpendicular to a radius of a circle at a point on the circle, then the line is tangent to the circle. So if line M, if the point on line M meaning point D, if point D forms a right angle with the radius, then we know that line M has to be perpendicular. Excuse me, has to be a tangent line because it is perpendicular. So we would say line M is tangent to circle C. All right. And then the final theorem that we're going to go over today is that if two segments are tangent to a circle from the same external point, so in this case the external point would be right here, point A. If they are tangent to a circle from the same external point, then the segments are congruent. So in this case, what that is saying is segment AB would be congruent to segment AC. And that's what we're going to write here. And those are all the theorems and definitions that you'll need. You can use those and apply those to some problem solving situations in the exit ticket and the homework. Overall, the most important thing to remember is that tangent lines intersect in one place on a circle, and chords are segments that the endpoints are on the circle, and a secant line is just that. It's a line that goes through the circle. So if you remember those basic definitions, then the theorems make more sense. And that's today's lesson. Thank you.